Okay, Watkins, here we're in journal page 38, finding complex solutions of quadratic equations. To solve a quadratic function, the function is set equal to 0. The solutions to a quadratic function are the x-intercepts, also called the roots and or zeros. There are three types of solutions to quadratic functions: two real solutions, one real solution, and non-real solutions, or what we call imaginary solutions. There are three algebraic ways to solve a quadratic function. 1, factoring. 2, completing the square. 3, quadratic formula, which is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Now the discriminant is b squared minus 4ac, and it tells us how many solutions are. When d is greater than 0, it's two real solutions. When d is equal to 0, it's one real solution. And when d is less than 0, it's non-real solutions. Okay, let's take a look at example number 1. Solve the equation by completing the square. State whether the solutions are real or non-real. Give your answer in simplest form. Now, to complete the square, first we're going to subtract 1 from both sides. So we have x squared plus 6x equals negative 1. Now, to complete the square, what you do is you take the number in front of x, divide it by 2, and square it. But because of equality, what you do to one side, you have to do the other. So that's plus 6 divided by 2 squared. So we have x squared plus 6x plus 6 divided by 2 is 3. 3 squared is 9. Okay. And we can use our calculator here to do negative 1 plus parentheses 6 divided by 2. Parentheses 6 divided by 2 squared is 8. Okay, so this equals 8. Now, the reason we did this is now this is immediately factorable. So that's parentheses equals 8. X and x makes x squared. And then 6 divided by 2 squared is 3 squared, which is 9. This number right here is our factor. So x plus 3, x plus 3. Okay, so now x plus 3 times x plus 3 is x plus 3 squared equal to 8. Now we can take the square root of both sides. Remember, plus or minus. Now the square root cancels the squared. You're left with x plus 3 equals plus or minus the square root of 8. We can subtract 3 from both sides. So x equals negative 3 plus or minus the square root of 8. Now we can reduce the square root of 8, and we can write that as x equals negative 3 plus or minus the square root of 4 times 2. And the reason we do that is because now we can take the square root of each separately. So square root of 4, square root of 2. So that x equals negative 3 plus or minus the square root of 4 is 2 times the square root of 2. Let's see if I can get my marker to work a little bit better. All right. So there are two real solutions, which are negative 3 plus 2 square roots of 2 and negative 3 minus 2 square roots of 2. All right, go ahead and finish up example number 1. Let's take a look at example number 2. Solve the equation by completing the square. State whether the solutions are real or non-real. Give your answer in simplest form. So first off, we're going to subtract 6 from both sides. So you get x squared plus 4x equal to negative 6. Now to complete the square, we're going to add 4 divided by 2 squared to both sides. Okay, so then that's x squared plus 4x. 4 divided by 2 squared is plus 4 equals negative 6 plus, and let's go ahead and put that in our calculator. So that's negative 2. Now, remember 4 divided by 2 squared is 2 squared, which is 4. That 2 is our factor, so this becomes x plus 2, x plus 2 equals negative 2. Well, this is x plus 2 squared equals negative 2. Take the square root of both sides, plus or minus. Cancels the square to get x plus 2 equals plus or minus. Now, the square root of negative 2 is the square root of 2i. Subtract 2 from both sides. Get x equals negative 2 plus or minus. And you can actually put the I in front. I square roots of 2. All right, there are 2 non-real solutions, negative 2 plus I square roots of 2 and negative 2 minus I square roots of 2. All right, go ahead and finish up example 2. All right, let's take a look at example 3. Solve the equation by completing the square. State whether the solutions are real or non-real. Give your answer in simplest form. So we already have this number on this side, so then now all we need to do is x squared minus 7x plus negative 7 divided by 2 squared equals negative 24 plus negative 7 divided by 2 squared. So this is x squared minus 7x plus negative 3.5 squared equals, we can go and get that number. So negative 24 plus parentheses negative 7 divided by 2 squared is negative 11.75. Okay, now let's go ahead and find out what negative 3.5 squared is. So 12.25. So that's x squared minus 7x plus 12.25 equals negative 11.75. So this becomes x minus 3.5 times x minus 3.5 equals negative 11.75. So then this is x minus 3.5 squared equals negative 11.75. Take the square root of both sides, plus or minus. Cancel to get x minus 3.5 equals, now the square root of negative number is I, so that's plus or minus I square roots of 11.75. We can add 3.5 to both sides. So x equals 3.5 0.5 plus or minus I square root of 11.75. Okay, so there are two non-real solutions, 3.5 plus I square root of 11.75 and 3.5 minus I square root of 11.75. All right, go ahead and finish up example 3. All right, let's take a look at example 4. Without solving the equation, state the number of solutions and whether they are real or non-real. So we're going to use the discriminant, which equals b squared minus 4ac. This is a, this is b, this is c. So the discriminant equals b squared, which is 3 squared minus 4 times negative 16 times 13. Let's go ahead and use our calculator. So 3 squared minus 4 times negative 16 times 13 is 841. All right, which we can use D for discriminant. So the discriminant equals 841, which is greater than 0. So there's two real solutions. Okay, the discriminant is 841. Because the discriminant is positive, the equation has two real solutions. All right, go ahead and finish up example 4. All right, example 5. Without solving the equation, state the number of solutions. Okay, so remember the discriminant, which we're going to call D, equals and got a little out of control there. Discriminant equals b squared minus 4ac, where this is a, this is b. Oh, no, wait a second. We have to have everything on the other side before we can have a, b, and c. So we need to subtract 3 from both sides. So now we have negative 1x squared, which is the a value, minus 2 divided by 7x, which is the b value, minus 3, which is c, equal to 0. Make sure a, b, and c are on the left side and it's equal to 0. So now that equals negative 2 divided by 7 squared minus 4 times negative 1 times negative 3. So let's go ahead and put that in our calculator. Parentheses, negative 2 divided by 7 squared minus 4, parentheses, negative 1, parentheses, negative 3. Let's just go and round that to one decimal place. So D equals negative 11.9, which is less than 0. So there's two non-real solutions. Okay, so the discriminant is negative 11.9. I don't know why the box is that way. We don't need that. Because the discriminant is negative, the equation has two non-real solutions. Let's take a look at the next example. All right. Now, before we do anything else, we need to move everything to one side. So we're going to add 16x to both sides. So we have 4x squared plus 16x plus 16 equals 0. Now we have a, b, and c. And let's just write d equals the discriminant, which equals b squared minus 4ac. Okay, so that's 16 squared minus 4 times 4 times 16, which, when you put this in the calculator, it'll equal 0. Since the discriminant equals 0, it's one real solution. The discriminant is 0 because the discriminant is 0. The equation has one real solution. All right, go and finish up example 6. All right, solve the equation using the quadratic formula. Okay, so this is 1, this is A, this is B, this is C. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so now let's plug the numbers in. So that's equal to negative b, which is negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 29 divided by 2 times 1, which equals, a negative times negative is positive. So that's just 8 plus or minus the square root. Let's go ahead and plug the discriminant in the calculator and get that number. So parentheses negative 8 squared minus 4 times 1 times 29 is negative 52. Okay, divided by 2. So that equals 8 plus or minus. We know that it's negative, it's imaginary. So I square roots of 52 divided by 2, which equals 8 plus or minus I. We need to see if we can write 52 reduced. So we need to find all the perfect roots. So let's try 2 squared, 4. So let's try 52 divided by 4. That's 13. So we can rewrite this as 4 times 13. Okay, divided by 2. Now, we can now take the square root separately. So square root of 4 and the square root of 13. Okay, so that equals 8 plus or minus, the square root of 4 is 2, so that's 2i square root of 13. And then I can divide each of these by 2. So 8 divided by 2 is 4, plus or minus, that's 1. So that's I square root of 13. So the solutions are x equals 4 plus I square root of 13 and 4 minus I square root of 13. All right, go ahead and finish up example 7. All right, let's take a look at example 8. Last example. Solve the quadratic equation using the quadratic formula. Okay, so this is 1. So that's A, B, and C. Okay, so quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, negative b, so negative 30 plus or minus the square root of negative 30 squared minus 4 times 1 times 100 divided by 2 times 1. Well, a negative times negative is a positive, so it's 30 plus or minus the square root. Let's go ahead and get that in the discriminant. So parentheses, negative 30 squared minus 4 times 1 times 100 is 500. Divided by 2. Now, we have x equals 30 plus or minus. We need to see if we can reduce that square root. So, let's do 2 squared. 500 divided by 4 works, but let's see if we can go further. 3 squared's not going to work. 4 squared might work. Let's try 500 divided by 16. That didn't work. 5 squared has a good chance of working. Let's do 500 divided by 25. That's 20. So far that's our best option, but let's go a little further. 6 squared. So 500 divided by 36. And then 7 squared. 500 divided by 49. Let's try 8 squared. 64. Now, it occurred to me, this works, but maybe a better way is, why don't we do this? 500 divided by 9 squared. Nope. Let's try 500 divided by 10 squared. So that means we have 105. Okay. So we can rewrite this as 100 times 5. Okay, divided by 2. So then that's equal to 30 plus or minus. Now we'll take the square root separately. So the square root of 100 is 10 times the square root of 5. And then we can divide both of these by 2. So that equals 30 divided by 2 is 15. Plus or minus 10 divided by 2 is 5. Square root of 5. Okay, so the solutions are 15 plus 5 square roots of 5 and 15 minus 5 square roots of 5. All right, go ahead and finish up your example, start working on your assignment, and have a wonderful Wildcat day.